An exponential function is a function where the variable is located in an exponent. Examples of what an exponential function might look like, something like y equals 3 to the x power, or y equals 5 to the x plus 2 power. Anytime the variable is in the exponent, you have an exponential function. We're going to begin working with exponential functions by just learning what they look like when they are graphed. So we are being asked to plot 5 points on the graph of the function and draw the asymptote. Then we are going to graph the function. The first one we are going to look at is f of x equals 5/3 being raised to the power of x. When your exponential function contains an exponent of plain x, it's not having anything added or subtracted to it, it's just plain x. My suggestions for what points to use are -2, -1, 0, 1, and 2, as you see in the table that I have created. So we're going to start by putting -2 in for x. When we do that, we will have 5/3 to the -2 power. Remember that to make the exponent positive, we flip the base. We use the reciprocal, so it becomes 3/5 to the +2 power. Now, square the top, square the bottom, you get 9/25. So the answer for -2 is 9/25. Put in -1. 5/3 to the -1 is the same thing as 3/5 to the +1, which is just 3/5. So the answer for -1 is 3/5. For 0, 5/3 to the 0. What you need to remember is anything being raised to a 0 power always equals 1. First power, 5/3 to the first is just going to be 5/3. 5/3 squared, square the top, square the bottom, you'll get 25/9. So let's plot those points. At -2, we are at 9/25, which is a very small fraction. So we are very close to 0. At -1, we're at 3/5, so we're still less than 1. At 0, we're at 1. At 1, we're at 5/3. Now recognize that that's 1 2/3. So we're a little bit above 1. And then at 2, we're at 25/9. That is 2 7/9. So we are almost to 3 when x is 2. The asymptote is the x-axis. This graph will get closer and closer to the x-axis, but will not cross the x-axis. The graph itself to the negative gets closer and closer to the asymptote. On the positive side, it's just going to get larger and larger forever. On our second example, we have the function of f of x equals 4 to the x. Again, because our variable exponent is plain x, we're going to use what I call the old standbys of -2, -1, 0, 1, and 2 as our substituted numbers for x. Starting with -2, we would have 4 to the -2, which would become 1/4, the reciprocal of the base, to the positive 2, square the top, square the bottom, you get 1 over 16. 4 to the negative 1 becomes 1/4 to the 1, which is 1/4. 4 to the 0, anything to the 0 is 1. 4 to the first is 4, and 4 squared is 16. So at -2, we are at 1/16. So we are very, very close to the x-axis again. At -1, we are at 1/4. 0, 1, 1, 4, and 2, 16. Our asymptote is still going to be the x-axis. And then when we plot to the negative side, we are getting closer and closer to the x-axis, but not crossing it. To the positive side, we are increasing more steeply than the first graph, but having the same general shape. Next, we're going to talk about domain and range for exponential functions. We are given the graph of an exponential function and being asked to find domain and range. So remember that domain is left to right. As we move from left to right, what's happening? Well, we've got an arrow on the left end and an arrow on the right end telling us that this thing goes left and right forever. So it's all real numbers, which we write as -infinity to infinity. For the range, we go from the bottom to the top. So when we come from the bottom, what's happening? That graph is going downward forever. So it's coming from -infinity. Where is it stopping? It's getting closer and closer to that asymptote. That asymptote's occurring at the y value of 3. But because it never crosses the asymptote, the 3 is not included, so it gets a parentheses. For this second graph, when we talk about the domain from left to right, what's happening with this graph? We've got arrows on both the left end and the right end, so it's again all real numbers, -infinity to infinity. For the range, going from the bottom to the top. This one is a little bit different because this graph doesn't start until the asymptote. That asymptote is going through the y value of -4. So it starts at -4, and because it's an asymptote, it's not included, so it gets a parentheses. And then the graph goes upwards forever, so it goes to infinity. There's a special exponential function that is used frequently in science applications and also in some business applications. It is f of x equals e to the x. The number e is similar to pi. It is also irrational, exactly the way pi is irrational. The number e can be approximated by 2.71828, but it does continue forever. We're being asked to evaluate this exponential function of e using our calculators and to round our answer to the 1,000th. Remember, the 1,000th is 3 decimal places. To use our calculator to solve this problem, we are going to use the e to the x function on our calculator that is found right here above the ln key. In order to access that, you're going to press the second key and then that ln key. When you have pressed the second and the ln key, you should see this e with a caret and a parentheses showing on your calculator screen. Type in the power of E that you are finding, which in this case is 1.2, and then close your parentheses. Hit your equals or enter key, and you should see this number of 3.32011, yada, yada, yada. So rounding to the thousandth place, the third decimal place, E to the 1.2 power is approximately 3.320. When you are doing problem B, 300e to the 1.4 power, type in your 300 times, do the second ln, put in your 1.4, and you should be getting a number of 1,216.560. On C, when you're doing the 50 times, second E, put in the negative 0.35, close your parentheses, hit your enter, you should be getting 35.234.